solutions in aqueous solutions. Now here, what is solution? As we discussed before in our experiment, solution is a homogeneous mixture of two or more than two substances. Suppose I prepare NaCl in water. I dissolve NaCl in water. Now it forms a homogeneous mixture. Now this homogeneous mixture is known as solution. Now this NaCl present in a smaller amount is known as solute, and this water is present in larger amount, that is known as solvent. So what is solute? Substance present in the smaller amount. And what is solvent? Substance present in the larger amount. Okay friends, here we have some examples of solution. Soft drink, it is homogeneous mixture, and solvent is water, and solute sugar and carbon dioxide, because it is also solution. Now air is also a homogeneous mixture, so we can call it solution. And in air, nitrogen is considered as a solvent. Why? Because it is 78%. And other gases, oxygen, argon, methane, sulfur dioxide, sulfur trioxide, carbon monoxide, all these gases are solute. And solder, we have discussed this in our chapter number 1. It is also homogeneous mixture. And in solder, what is solvent? Lead. And solute, here is an example. Okay, we have already discussed it. Okay. Now, okay friends, suppose here I take water and I dissolve NaCl. So it will form homogeneous mixture, and that is known as solution. So I prepare another solution of glucose C6H12O6 in water. Okay, I prepare third solution and here I take benzene C6H6 and I dissolve ether. Ether is miscible with this benzene, so it will form a homogeneous mixture, and we say it is as a solution. Here NaCl solute and water is solvent. Here glucose is solute, water is solvent, and here ether is solute and benzene is solvent. Okay. Now, when your solvent is water, then a solution is known as aqueous solution. Aqueous.
Aqua is a Greek word, means water, like.
Very good, excellent. So if your solvent is water, okay, then a solution is known as aqueous solution. Aqueous solution. So is it an aqueous solution?
Yes.
Yes. Is it an aqueous solution?
Yes.
Is it an aqueous solution?
No.
No, it is not an aqueous solution.
No.
Okay, it is known as non-aqueous solution. Non-aqueous solution. Aqueous solution. Okay, so if solvent is water, then solution is known as aqueous solution. If solvent is not water, then it is non-aqueous solution. Okay, we shall discuss only aqueous solutions. It means we prepare and we shall discuss those solutions in which our solvent is water. Okay. Now, okay, friends, if electricity can pass through this solution, when you pass electric current, then what happens? This solute is known as electrolyte. And when electricity cannot pass through the solution, when this solute is known as non-electrolyte. Now question is, why this is electrolyte? Why electricity can pass through this solution? Why electricity cannot pass through this solution? Yes. Now what happens here? It is ionic compound.
Ionic
When you
compound.
dissolve
Yes.
ionic compound in water, it changes to ions. It
Yes.
changes to positive ion and negative ion. Now due to movement of these positive and negative ions, electricity can pass through the solution.
Yes.
Okay. Now here when you dissolve this glucose, there are no ions because it is a molecular compound. So
Yes.
there are no positive, no negative ions. So electricity cannot pass through this solution. Okay.
Okay.
Good. So electricity passes through the solution due to movement of the positive and negative ion. Good. Okay, students, now we have two types of electrolytes. Strong electrolyte and weak electrolyte. Now, what is strong electrolyte? What is weak electrolyte? Now, here, when you prepare solution, of NaCl, suppose we shall discuss only NaCl. Okay, and another solution. It is the solution of HF, hydrogen fluoride gas. Okay, now what happens here, boys? Suppose you dissolve 400 molecules of NaCl in water. Now all molecules will change into positive and negative ions. So when any ionic compound changes to ions, this is known as dissociation. Dissociation. So if all molecules will change into ions, then we say its dissociation is 100%. So if 100% dissociation, it means more positive and more negative ions are present. So more electricity will pass. If more electricity will pass, we say it is strong electrolyte, strong electrolyte. Okay. But in other case, when we see this HF, suppose we dissolve 400 molecules of HF in water. Only 8 molecules of HF changes to positive ion and F negative ion. And all other 390, suppose 392 molecules, it will not change into ions. So this is not 100% dissociation. We say it is not completely dissociated, or we say another word, partially dissociated. Okay, so if it is not completely dissociated, we say it is weak electrolyte. Weak electrolyte. And if completely dissociated, 100% dissociation, we say it is strong electrolyte. Okay. Now, next question is how we know it gives us 100% dissociation. It is strong electrolyte, and how we know it is weak electrolyte. Is it? Very good question. Now we shall discuss in our next slide. And now again here is electrolyte I told you, and what is non-electrolyte? Now non-electrolyte, no electricity passes, and in weak electrolyte small amount of electricity passes, and strong electrolyte more amount of electricity passes. Okay. Now why electricity passes? Due to positive and negative ions, and strong electrolyte 100% dissociation, weak electrolytes not completely dissociated, just like acetic acid. Okay. Now in non-electrolytes, I already told you. Okay, now this is answer of your question, boys. How we know it is strong electrolyte, weak electrolyte, or non-electrolyte? Remember three things. all acids strong acids and bases and those ionic compounds which are soluble in water, soluble. These are strong electrolyte acids. There are some exceptions. We shall not discuss those exceptions. Should know all acids, bases, and soluble ionic compounds are strong electrolytes. Number one. Rule number two. All molecular compounds are non-electrolytes. Molecular compounds. So if I say C12H22O11, it is strong electrolyte or non-electrolyte?
Non-electrolyte.
It is non-electrolyte. Why? Because it is molecular compound. If I say SO2, it is strong electrolyte or weak electrolyte or non-electrolyte?
Non-electrolyte.
It is
Non-electrolyte.
non-electrolyte. Why? Because it is molecular
Molecule.
compound. Very good. Okay. Okay, friends, now come to weak electrolytes. Now from weak electrolyte, you will say these first four. Here, acetic acid, hydrogen fluoride, HNO2, nitrous acid, and NH3, ammonia. So these are weak electrolytes. There are many exceptions. We shall not discuss those exceptions. Acetic acid is a weak electrolyte. Yes. Why? Because it is not completely dissociated. Its dissociation is not complete. Why? What happens when you dissolve acetic acid in water? It changes to negative ion and positive ion here. But after some time, this negative ion again attaches with this positive ion and both becomes acetic acid again. So this is a reversible process. Okay, it is a reversible reaction. First it changes from molecule to ions, and then after some time it changes from ions to molecules. Okay, so what is the reversible reaction? The reaction which can occur in both directions, that is reversible reaction. And these are weak electrolytes. Okay, now acetic acid is a weak electrolyte because its ionization in water is incomplete. Okay, now, okay students, before going to next topic, I want to ask you one question. When you dissolve NaCl in water, do you see this NaCl in water?
No.
No.
No, we can't.
Why?
Homogeneous.
Why?
Homogeneous pressure.
If homogeneous, you are dissolving NaCl in water in too much amount, then why you can't see this NaCl in water? This is my question.
No,
Where it goes? Why it
We-
disappears?
because the water is more than
Dissolved in water.
If water is more than.
yeah.
If you see here small thing in water, then why you can't see this NaCl?
This is
Water is
NaCl.
transparent.
that are inside the water. In the middle.
Okay. Okay, friends, what happens here? When you dissolve ionic compound, these compounds change to positive and negative ions. Is it?
Yes.
Now, if I ask you a question before going to this discussion, if I am here, sorry, this is me. If my drawing is not good, forget about this one. Okay, I am here. Okay, now if 6 or 7 students are covering me from all directions, can you see me?
No.
No. So same thing happens here. What happens? These positive ions and negative ions, these are surrounded by water molecules from all directions. That's why you see only water molecules. You can't see these positive and negative ions. So this process is known as hydration. The process in which water molecules surround an ion is known as hydration. The process in which an ion is surrounded by water molecules is known as hydration. So definition is important. Here it is. Now you see NaCl, it is Na positive and this is Cl negative. Now These are water molecules. These are water molecules. So definition is here. Hydration is the process in which an ion is surrounded by water molecules arranged in a specific manner. So definition is important. Okay.
What's meaning of manner, doctor?
In a specific manner mean, now in water, look at this. What is the structure of water? In water, how many
It's
atoms?
two H
Three
and one O.
atoms.
Three atoms.
Okay, very good. So here partial positive, partial negative, partial positive. Now what happens if it is positive ion here in case of sodium positive ion? Now you see here it is Na positive. Now it is positive ion. So water, what is the side of water molecule? Oxygen. Oxygen will be towards this Na positive. Now you see it is towards oxygen. Here Cl is negative ion.
So it's surrounded by H.
Very good. So direction of a hydrogen will be towards this chlorine. It is known as specific manner. Okay.
Yes. Yes.
Okay. Good. Good.